Hello again, Scratch Buddies. This is Chris going over a new lesson here today. Last time we were doing that side scroller and we saw me draw a cloud, and I don't really draw that well. But lucky for us, or for me, Scratch provides a lot of different characters, and so you can put together a little story. And later on, we'll go into more about how to draw your own characters or pull your own characters off the web. But today, I want to show you a little bit about how Scratch can itself do some drawing, whether it's Scratch Cat or some other characters. It's this section here called the pen, where we can clear, we can do a stamp, we can put the pen down, pen up, change the pen color, change the pen shade, change the pen size. And so there's some drawing stuff that Scratch can do. And, because I tried teaching this stuff and making sure it's relevant to coursework and things and math, we're going to draw some shapes today with, Scratch Cat can draw, but there's some other cool costumes too. So if we just go to costumes and we see these two costumes of the cat, or we can add our own from the library. Let's go to things. And if we scroll down a little bit, buildings don't draw, candles don't draw, donuts don't draw. But starting with a P, you can get a pencil. And pencils do some drawing. All right, so let's try the pencil. And let's try out some of these things. And the easiest way for me when I start to play around with some new things is just maybe have an event when I hit the space key. Oh, let me blow this up for you a little bit. When I hit the space key, I want something to happen. Let's put our pen down. And when we run this, all right, the pen's down, but nothing happens. When you're drawing on paper, you put your pen down, and then what do you have to do? Move a little bit, right? So what happens if we put the pen down and we move 10 steps? Oh, there you go. A little line is coming there and being drawn, though it's strange because it's being drawn from the middle of the pencil and not the pencil tip. And this is because our pencil, sort of the center of it, if we were to start rotating and things, is going to rotate around the center there. And so that's where it's drawing. And that makes sense when your fish is swimming around an aquarium or something. But that doesn't make as much sense when we're trying to draw with a pencil. So what Scratch does, it allows you when you're in this costume to set the center location. And you use this item here, which says set costume center. I believe that's what it says underneath there. And so right here, you can see the center is in kind of the middle of where the pencil is. But we want to make the center the pencil tip now. Now that we've done that, we can see when we start rotating, we're rotating around that pencil tip. And if I start to draw, it looks like it's coming out of that pencil tip, right? So that is a little more realistic what we want. And that comes out, again, from setting the center of your costume. Sometimes if you find your rotations aren't happening the right way or anything like that, don't forget this little bit. So each lesson we try and go over a couple new things, and these are just going to be tools, various tools you put in your tool belt. When you're developing your own code and writing your own programs, you'll remember, oh yeah, I had that little bit here. I remember how to change the center. Sometimes that's useful if you want to, let's see, when people are animating a character and they want the arm to swing, the whole character doesn't move around, but just the shoulder or the arm. And it doesn't pivot from the middle. It pivots from the point to your shoulder, right? So that would be somewhere where you could use that. We'll probably go into that tutorial a lot later on. If not, remind me and we'll get back to it. Okay, so now back to our pencil. When the space key is pressed, we're drawing now. And so that looks good. And let's start to draw some shapes. So I think the easiest shape for us to start with would be a square, because people know how to define squares pretty well. And let's see, if we move 10 steps, how do we draw a square? Well, we need to then turn 90 degrees. And then what do we have to do next? Draw another edge that's the same length. And then turn 90 degrees again. Right? And we want to do that 4 times. So I've done that 2 times. I'm tired of that. going back and picking all up. So I'm going to copy this one. That gives me a block of 2. Oops, I copied in the wrong place. Let's just throw that away. I need a copy starting from moving 10 steps. And let's see how that works. It drew our square. And I drew it kind of fast, so we didn't really see it get drawn. If we want to put in a little weight, every time it's done its movement, you can see that, but well, how can we tell it was a new square, right? So we have to be able to erase things. So let's hit clear. And there goes our pencil, drawing it around. Maybe 1 second is too long. 0.1 seconds. And this is only if you want to see it being drawn. Right? It looks a little more fun maybe if you get to see it drawn. This clear, let's add a key to that so I don't have to keep clicking on it. There is no delete key in this list. Up, down, right arrow, left arrow. Maybe the left arrow is like it. Like a delete. Oh, we go 0. 0 says 0 everything out. Clear it all out for me. And draw me a square. Okay. But as a programmer, I don't like seeing all this duplicated code right here where we do the same thing over and over and over again. If I see something like that, that's a pattern and I want to compress it. Do you know what I mean? Let's make that code a little bit smaller, a little bit easier for us to deal with so we get more code on the screen doing other things. And what should we be doing with these things? If we find we're doing the same thing over and over again, we should put it into a loop, right? And here we want to repeat this. We don't want to repeat it 10 times. How many sides does a square have? 4 sides, right? So here I need to move, turn, and wait. So let's do that. And now if I repeat that 4 times, I should get a square. Well, let's blank out. I get a square still, right? And now it's a lot easier because say, hey, maybe I want to make my square a little bit bigger. I don't have to go change it in 4 places. I just change it in 1 place. And now I have a bigger square, right? And, oh, that didn't end up there because we were too close to the edge. That's interesting. So sometimes the sprites can't go all the way up as high as they want to go. So I move it around, and there's our square. Okay. We've done a little bit here of compressing it, and now we can add some other shapes. We know how to clear it. We know how to draw a square. Let's add a triangle. How will we add a triangle? Well, let's just add another. Well, we can add it or we can copy this. Let's copy this. Since we know a triangle and a square are kind of the same thing. We don't want to always do both on space. So let's change triangle to T. Maybe let's change our space, our square to the S. So now an S will draw a square. A T will draw a triangle. Well, it draws a square. All right, how many sides does a triangle have? It has 3 sides. So we don't want to draw it so many sides. All right, well, wait. Now we just drew 3 sides of a square. So we weren't turning enough degrees, right? If we change the number of sides, we probably have to change the number of degrees. And what happens if we do more? We do 100. That's closer, but it's still, we started here. We went over here, went there, went there. We didn't quite get back to where we needed to be. Let's try 110. Closer, we started there. We didn't get quite back to where we wanted to get to, though we are getting kind of a cool pattern here. Let's try 120. And it's tough because of this pattern. Let's hit 0, clean it out, and there's our triangle, right? So 3 sides, 120 degrees, 4 sides, 90 degrees. Let's make a pentagon. And a pentagon is more than just a building in Washington, D.C. Pentagon is a shape that starts with the letter P, not Q. And it has 5 sides. Now, if we do this one, 5 sides, it just means we draw over 2 extra sides of our triangle. That's the wrong number of degrees. So should a turn be more or less than 120? Well, we went to 4 sides, we went down to 90 degrees. So when we go to 5 sides, we're probably going to go down again. But how much do we go down? And this is where math comes in a little bit. All these shapes have the same number of degrees in them because they end up at the same starting point. So 4 times 90 is 360. 3 times 120 is 360. So to find out how many degrees we need to turn for a pentagon, we divide 360 by 5, which 3 goes into 36, or sorry, not 3, 5 goes into 36, 7 times? Remainder 1. So then we have 10 there. 5 goes into 10 twice. And now when we hit the letter P, click outside that so that you don't put P in the number of degrees. There's our little pentagon. So we got a pentagon, a square, and a triangle. What's next? Let's do, it's got 6 sides. An octagon or the hexagon. Octopus has 8 legs, so an octagon probably has 8 sides. Hexagon, let's repeat 6 times. 6 goes into 360. 6 goes into 36 6 times. 6 goes into 0 0 times. And so now we have an H. All right. And that one, everyone's getting a little bit bigger. You see the triangle? And then the square got a little bit taller. And it's because we're drawing each side the same length and starting out a little bit of an angle, which is kind of neat, right? Let's go do that octagon we were just talking about. Where's letter O? 8 sides. 8 goes into 36. Well, 8 goes into 36 4 times, remainder of 4. 8 goes into 45 times, so 45 degrees. You notice that's kind of the same as the square, which was 4 times for 90 degrees. We just changed the numbers a little bit. Uh-oh, that didn't work. What was wrong with that, you think? Oh, that was because we ran up on that edge again. Oops, I erased it on accident. So if we go up here, and we're too close to the edge and the pencil goes off, you can see this line right here was shorter than it wanted to be. So if I tried it again from down here, then we get it because it started from a good point. So maybe we should shrink our pencil down a little bit so we don't run into that so often. And maybe we want to change the size of some of these things a little bit too. We could try that. One thing would be nice would be able to move the pencil around so that we could draw other shapes wherever we want to, right? Maybe that'll be what we can reassign the space key to. So let's see. When the space key is pressed, let's move to where the mouse is. Uh-oh. Well, now that lets us draw however we want. Is that what we want? Maybe it is. Maybe it isn't. Is it easy to click and drag that guy around? Well, it's moving and drawing that line because our pen is down. So if we do pen up when the space key is pressed before we move there, now it moves around to where we want to go without doing anything like that, right? Okay. So let's see. Let's clear this again with 0. We can move our pencil over here. We can draw an octagon. Still too big. All right, let's cut down the size of our octagon a bit. Let's go to 50. Maybe our hexagon will be 60. Maybe our pentagon will be 60. Our square and triangle were okay, maybe. Let's clear this out. Try and draw another octagon, a hexagon, pentagon, square, triangle. So you have all these different shapes now, right? And what I liked having this conversation about was, or maybe, should it be instead of a space keys pressed? Maybe every time you draw something, we should go to where the mouse is. How about that? That might work better. So if we do this, let's just duplicate this little part and put it there. And now when the O key is pressed, I move over there and I draw my octagon. Right? And we can do that with everyone. We can get rid of it. Well, we can keep it so we can keep duplicating things. And which one did I miss? I need one more for the square. And then we can get rid of it. And you see when I push up here, it scrolls automatically for us. That's nice. And now everything got a little bit longer, so I need to move things around a little bit. Yours might not feel as crowded because you're not zoomed in so much, but it's always nice just to be able to read everything you're working on, right? And we get rid of this. And so sometimes I want to go through these design processes with you where we try something out and we say, hey, this might work better a different way. And it's okay. That's what's going to happen when you write your programs on your own too. You're going to find things don't work the way you thought they would, and you're going to change things a little bit, and it's fine just to keep moving things around. The arrow is too close to the edge for the square. So that's okay, right? That's all right to do. It's going to be a natural process, and I want you to be able to get comfortable with seeing some things that don't look quite right and knowing, hey, I can fix that instead of getting frustrated and saying, oh, programming's terrible. No, let's just fix it. So we move over here to draw a square. I move over here to draw an octagon. All right. What else can we be doing? Well, one thing that was kind of neat was when we were drawing those patterns. Another thing here. And so if we draw a pattern, it'd be interesting when we end to not be in this. Well, we're in kind of a strange alignment here to start with. So if I was to go say, hey, all squares are going to start by pointing 90 degrees. Then when I draw a square here, all right, then it's always going to come up with the first edge going this way. Is that what we want? Maybe. I mean, that looks like a square now, right? Because if I drew it where we were pointing in direction 45, then it starts to look like more of a diamond whenever I do it. But that's just a square on its side. Let's clear this out. Our square works. And our triangle works as well. It's always going down because that first edge is going to the right because that's the direction we're pointing in. So, I don't know. Is this something we always want? If we were to change it a little bit, let's see, we repeat 3 times, we move 100 steps, we turn 120 degrees, we wait a second. Well, that last turn of 120 degrees is what gets us going this way, which we really don't need to do. Right? So we could, how do we get around doing that last turn of 120 degrees? We could move 100 steps first and then only repeat it twice and then do our turn before we draw. And now what's going to happen here? It's kind of a little strange. Do you follow what happened? I drew the line first, and then I said, well, to finish out this triangle, I have to draw 2 more edges. And to draw them, I have to first turn, and then I draw, and then I turn, and then I draw, and I don't turn that last time. And that's what gives me this pattern here. But I don't know. That's a little strange logic. But it does create nice little patterns here. What do you guys think? Should we do that for some other ones and see what other kind of patterns we get? Let's clear this out. The square doesn't really... Square is a little boring because of that. But if we would do the same thing with the pentagon, where we move 60 steps first, do the turn first, and instead of repeating 5 times, only repeat it 4 times, what would happen there? And then we draw a second one. Oh, I moved the mouse, sorry. And so you get these little patterns. Let's clear it so I don't have a mouse there. And that's what 5 pentagons look like. And that's a nice pattern. What else? The other way you could do it, which is a little cheating, is just instead of going 6 times for our hexagon, let's go 7 times. And it's really just going to draw over that other edge. And it will, whoops, I don't want to do 700. What was I doing? I was trying to clear when I was in that field. So let's clear this. Let's draw the hexagon. And you see now it draws a little extra bit. And we're too close to the edge. Let's clear this out. Let's move over here. Draw the hexagon. And you see how it draws a little bit extra. And when it does that, that's what keeps it going the other way. And now, what does this look like? If you draw, how many did we draw? 6, 7 hexagons, 8 hexagons? Now it looks like 3 cubes in the corner. Who knew that was going to happen? That's pretty cool, right? And that's just from drawing hexagons over and over again. So there's 2 ways there to make it so that your second item is not going to be drawn at the same place that your first one was. And one way we just didn't turn that last turn when we started changing the size of our loops. And the other way was we did an extra turn just to get into a different spot. 2 different ways to solve sort of or create kind of the same effect. Let's see what happens with our octagon when we draw too many of them. Not too many of them, but many of them on top of each other. We get kind of that same 3D cube effect, but now I don't really know what kind of shapes these are. Got crazier 3D cube. All right. So these are some fun things. Like if you just start drawing, and this is where some of the fun of math comes into play. You just start drawing a lot of shapes over and over again, and you can see some patterns come out. And it's just driven by math. All right. I know what kids love doing in here, and that is changing the pen color whenever we're in a loop. So let's see what happens when we change the pen color. Right, and so now you have different colors coming into the pattern. And it looks nice. So you can draw all sorts of different colors. You can see that you can set your pen color to all sorts of different colors. Let's drag this over here, and you say set it to, and then you can click on what color you want it to be, right, by just mousing over the color. And how do they bring up a color picker? I don't know. I'll have to get back to you on that, of how to pick a color in there. Right now, if you click on it, you go click on some other color that you want it to become, it'll become that color. Maybe if you have a colorful sprite in here somewhere, you can pick it from there. But that's one way to change the pen color, and if you change it while you're drawing, then your lines will come out slightly different each time. Add some other dimensions of interest, and you draw over the lines, and now the lines will change. You could change the pen size if you want to have your pen size a little bit thicker, right? Maybe for octagons in this color, changing this color, we'll set the pen size to 3. Let's see what that changes for us. Oh, not 30. So that's one thing you should be careful of. Make sure you're out of the field when you're trying to hit 0 to clear things out. My mouse is here. Let's see what a pen size of 3 is. So there you see it's a little bit thicker. And we get this design going on. Okay. And one thing that I get into in classes sometimes is we've seen a 3, a 4, a 5, a 6, an 8-sided element. And then I ask the kids, how many sides does a circle have? And we'll get into various arguments. Some people say it's 2. It's got the inside and the outside. Not really what we're talking about, is it? Some people say it's got no sides because it's always just a curve. But I think the answer is really it's got an infinite number of sides, because imagine you have a can, right? And a can, when you look at it sideways, it's a circle. And when you put it on a table, one side is touching the table. And then you just roll it just a little bit more. Now another side is touching the table. Roll a little bit more. Another side is touching a little bit. And you can roll it into an infinite number of different positions there, even though they're just microscopically different than the other position. There's a bunch of them. And one way that I like to show that is through this little process here. We start with a triangle, then we drew a square, and then we added a hexagon or a pentagon, then a hexagon, then an octagon. And you notice the shapes start to get a little rounder, don't they? And so what would happen if we made it, let's see, let's duplicate our hexagon, and we'll call it our circle. So we'll go with C. And what happens if we wanted a 60-sided item? Then we would move how many steps? 60 goes in the 366 times, so 6 steps. And we're going to, not 6 steps, 6 degrees, but we probably do want to move just a few steps because it's going to be short. Let's see what happens there when we hit our C. It's starting to look like a circle, isn't it? And you can see at 60, it already looks like a circle. If we go up to more sides, 120, it'd look like a circle. What happens if we do 30 and we go 12 degrees, right? So we have the number of sides and we double the number of degrees. And let's draw our circle over here. Still looks like a circle. I mean, it's smaller because we're not doing as many steps. We're doing half as many steps. So you can see how, I don't know, at around, what's another number that goes in here? If we have this again, 15, then we'll need to double this, 24. Draw this circle over here. Still looks like a circle. Maybe if we make it bigger steps, 20 steps. Let's clear this. It doesn't quite look like a circle here. You can see kind of the chunks, right? But that's because we blew it up and we examined, oh, let's take a look at this under a microscope kind of, right? And see these really large edges. Okay, now that does look at. So if we go back to 30 and 12 degrees with the 30 steps, we're going to get a bigger shape. But it looks pretty close to a circle. It's getting too big. It's getting a little, I guess, started over here. So I use this as just a way to try and go through with the class how shapes, and when we add more and more sides to a shape, it starts to look like a circle. right? So maybe 5. And what did we say? We said 30 looked pretty good when it was small enough. And so that goes through our whole set of, well, let's make an octagon. Let's make a circle. Let's make a square. Let's make a triangle, triangle, triangle. If we were to make 4 squares, it would just look like a block. I think the one that was most interesting to me was the hexagon. When we got to just draw the hexagon over and I keep having the mouse in the wrong place. Hey, maybe the jumping to the mouse is not what we always want to do when we draw a shape. You guys play around with that, figure out what you want to do. But this, the way it drew 3 cubes, that's kind of my favorite. All right. Hopefully you guys picked up how we can get some drawing down with the pen. We can change its color. We learned how to do loops, and we learned about some of the patterns of all different shapes here when you go through geometry, and that when you draw things in a pattern, some other things come up as different patterns. With both the octagon and the pentagon had kind of a little flower, but the hexagon is the one that came with these 3D squares. All right. Thank you, and I hope there's a couple more things in your toolbox now so that when you go on and do your own creations, you can try and imagine some new things that are more than what we're doing right now. Bye-bye.